What's up, everybody? This is Titans of CNC. And last week we had our BOOMBASTIC show, and it was crazy. Crazy machining and crazy deals. In just a second, we're going to show you some awesome titanium milling, crazy aerospace part, just getting after it, and we did it live. But quickly, before that happens, I want to remind you guys, we got deals, and we still have deals, right? So titansofcnc.com/promo, go check it out. Deuce on machines, 25 to 30% off. Mastercam, Canametal, Blaser, Heimer, Mitutoyo, all of our partners coming to the table to bring crazy deals. We're not taking a cut. It's all about you guys. Get those deals, lift up your technology, lift up your shops. It's time to compete. Boom, let's go do this. It's at about a ½ an inch right now. So you gotta think, bare surface titanium, the end mill, the Harvey TE is just helicaling in, going straight into the titanium. The surface foot is about 205 on that surface foot. Once it gets to the bottom, it'll just start eating that titanium right there. Of course, we got to use the Synergy 735 from Blaser. You know, we run a lot of things dry for the cameras, right? But at the end of the day, when it comes to titanium, it comes to super alloys, you got to have that Synergy 735 on there, because otherwise you're going to have a ball of fire in that end mill right there. Machining titanium is no joke. Oh, we're almost to 1.5, so we're all the way down. When you look at this guy right here, we're gonna spend some extra time on it so you can see it cutting. We're gonna talk about the speeds, the feeds, the chip loads. As mentioned before, right now, I'm using the Harvey 1 TE. Stuart, my man, is running this machine, and we're at 205 surface foot. Our chip load is 0.0025, and that is taking a cut of 200 thousandths. Full depth at 1.5, axial, radial, 0.200, big cut. And listen to how it sounds, man. Oh, it's beautiful, it's beautiful. You guys running titanium, that's money right there. Document that, duplicate the process, make sure that you got the right coolant, right? It's the ingredients to the cake. Make sure you have the right coolant, right? We're using Synergy 735, but based on your application and material, you might use a different coolant. But this is what we love, and we love that it's clear and you can see it and it saves on tool life. We're also using the shunt, the pallet here, and this actually, it's a pallet, but it's a tombstone on top of the pallet that is from Shunk, and this thing is a beast, and we got Shunk vices on there. Absolutely amazing. Our tool holders are from Canametal, and the tool holders are dual contact 50 taper holders. And this machine, while we're taking these big cuts, the pressure on that spindle, like it's nothing. Like it's handling it like nothing. There's that rumble again. You hear that rumble? That's good. Shatter, that's bad. That's good. It's all about the ears and stuff. taking a nice deep cut in axial with a Harvey 3 TJDE. Oh, live on camera. I don't know if people really understand. Like, we're running at 57 inches per minute in titanium at over 2 inches deep, 3 times D, 10% radial, live on camera. And the tool could break, right? But it's not, because you gotta understand the data. You gotta have the experience. You gotta like look at the numbers. You gotta listen to it. And when you find that sweet spot, you just gotta be like, that's it right there. This is really long, so there's a little bit of a squeal to it, but I'm not worried about it, because I can hear underneath. I can hear that, and that's exactly what I want. And I know from experience that we've actually ran a ton of parts at that 400 surface foot, which this is, right? And I want to say 400 surface foot is no joke. Look in the Machinist handbook under titanium, and you will see that they say to cut it at about 175 surface foot. But what we've done is we're actually using a Mastercam OptiRough pass that allows us to peripheral mill. So we're going all the way down, axial in Z, all the way down, and then we're ramping in. Remember what I said, walking into the water from the beach, right? Don't jump off the dock, walk in. So we're coming into the material, we're taking a 10%, and we're just walking all the way around it, boom, boom, boom. The chip load is 0.0047. The range would be like, from low 4s up to maybe 5.3 when you're roughing, and that's what we're getting after. So. What do you think, Stuart?
It's good.
So we're proofing out a massive program live in titanium using the baddest end mill on the planet, the Harvey 3 TJDE. It's got the chip splitters, breaks it all up. I want to remind everybody, can of metal, these tools right here, not this specific TJDE, but like the Harvey 3, the Harvey 3 end mills, the Harvey 1 TE that we did the pocket with, and the Core 5, you can buy them as low as $41. Anybody, we went to Can of Metal, we said we need to get these tools in everyone's hands. We need a crazy low price. Let's look at volume instead. They came to the table, did a Titan discount promo. You can go to titansofcnc.com/promo, and anyone can buy these tools, 41 bucks. And like, we put them against anything. These guys last, we call them my son nicknamed them the zombie mill, because at Inconel 718 hardened for an aerospace job where we were losing. That's when we fell in love with them, because the tool, Harvey 3, came in and went. When everybody else couldn't get past 90 minutes in cut, it went 7 hours. It chipped, we kept going, and it kept cutting, and we named it the Zombie Mill. That's our nickname. Ooh, that's a lot of material, man. exact speeds and feeds that we use when we make crazy aerospace parts. You can look at this part. This is a crazy part. This is a beautiful titanium part. We're gonna come out with a YouTube video down the line where we show every tool. We do the surface finishes. You know, like this is roughing, but then we're gonna relax it. We're gonna come back and we're gonna kiss the baby. We're gonna kiss the baby. We're gonna bring those tolerances right in perfect, right into tense, make it so beautiful. There's a time to rough. There's a time to come back and kiss it right into tolerance. So you can see right now, the part is awesome. It comes out, boom. You got like your 5 pockets. You got some cutouts on the side, and then the center pocket actually comes down, kind of 3D, kind of comes down and stuff. So right now, it went around the whole thing, boom, boom. After all the pockets were done, it's coming in, bang, 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 all up inside here. And then it's gonna come on the other side and it's gonna start doing the pocket, they're like pockets, but they're open on the sides. It'll start doing those. Then it'll come to the top and start doing some 3D, 3D work, boom, 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 walking up different sides and stuff, and it'll be awesome. Remember, this is the chip load on this is 0.0047. Surface foot is 400. 400 in titanium. 3 times D axial, 10% radial, mint. Sounds great. The part is looking beautiful. It's looking beautiful. So now it's just doing some small little cuts, just taking care of the small things, and then it'll get back to getting after it. It's just doing right now is just doing the intricate work, just working the details. A lot of the big roughing has already been completed. We still have to do some roughing on the corners and stuff, and looks amazing. know, one thing I'll say is, I can't stress the fact enough, it's all about the variables. If you look at the tool path, you'll see that I'm taking a nice arc right into that material. And that's why you don't hear like when I enter the material. It's just like boom, boom. So gentle. It's just about bringing that arc, like just gliding right into that material, into the cut, and doing the same thing when you come out. When I come out, because I want a smaller tool path, I have a smaller out, but I'm still, it's a gradual out, and that's why you don't hear any banging on that tool path. It's very, very important when it comes to tool life. People look at tools lasting, but you gotta think, like when you have a tool like that, you have to you gotta come in, you gotta understand the cut, you gotta understand the parameters, and you just gotta give it its best shot. A lot of people wanna use regular end mill holders and do a side set screw or something. We use a Hydroforce from Kennametal. It holds it secure and true. Once you push it to the side, it's banging a little bit. You know, even a gradual bang when it comes to advanced manufacturing is bad. So it's just all the small little details in manufacturing.